Good morning, students. Welcome to the third lecture of soft computing. In the previous lecture, I have discussed about the crisp set, types of crisp set, and the different operations that we can perform on the crisp set. The different operations that we can perform on the crisp set are union, intersection, complement, and the difference of two set. In today's lecture, I am going to discuss about the properties of a crisp set, fuzzy set, membership function, and the types of membership function. So let's start with the properties of a crisp set. If there are two sets A and B and there is a universal set U, then the first property is a commutative property and it states that A union B is equal to B union A, or A intersection B is equal to B intersection A. This law can be proved using a truth table. Now the second law is your associativity law. It states that if there are three sets A, B and C, then the associativity between three sets can be proved using A union B intersection A union with B union C is equal to A union B with union C, or A intersection with B intersection C is equal to A intersection B with intersection C. The third rule is the distributivity, and it states that A union with B intersection C is equal to A union B intersection A union C, and A intersection with B union C is equal to A intersection B union A intersection C. The fourth law is your idempotent law, and it states that A union A is always equals to A and A intersection A is equals to A. Transitivity law states that if there are three sets A, B and C, if A is a subset of B and B is a subset of C, then A is a subset of C. If two sets are said to be subset, if let's assume that A and B are two set and A is said to be a subset of B only when all the elements of A is present in the B. Now comes to the identity law. Here phi represents a null set and X represents the universal set. So the identity law states that A union A set A union phi is always equals to A, and A intersection phi is always equals to phi. And it also states that if A is a set and X is a universal set, then A union X is equal to X and A intersection X is equal to A. Now, involution law states that for any set A, this property states that double complement of A is always equals to A. And the law of contradiction states that A intersection complement of A is always equals to phi, which is a null set. Now comes to the De Morgan law. It is a very important law and supports in providing tautologies and contradiction. This law states that complement of A union B is equal to complement of A intersection complement of B. Also states that complement of A intersection B is equal to complement of A union complement of B. This law is used in proving the tautology and the contradiction. What is a tautology? If a output of a truth table contains only true, then it is a tautology, and if it contains only false, then it is a contradiction. So these are the different properties of a crisp set, and using these properties we can prove the different tautologies and the contradictions. Now comes to the fuzzy set. Now the question is, what is a fuzzy set? A fuzzy set is a set where degree of membership function lies between 1 and 0. It allows partial membership. Fuzzy sets can thus better reflect the way intelligent people think. If we take a crisp set, there is also a membership function which is only 1 and 0. In a crisp set, if the element belongs to the set, the value is 1, and if the element does not belong to the set, then the value is 0. So, either in crisp set, the membership function is always 1 and 0. But in fuzzy set, the membership function lies between 1 and 0. Thus, it better reflects the way intelligent people think. For example, let's see. An intelligent person will not classify people as their friends or enemies. There is a range between these two extremes. For example, let's see that if you have a friend, you put the friend in different categories. Like some are best, one is best friend, some are common friends, someone is very your close friends, someone does not come to your friend list. So these are the different categories you put your friends. So these are some adjectives or the linguistic terms that is used by a human beings, and these all linguistic terms can be answered using a fuzzy set. Like vague human expressions such as tall, hot, cold, etc. can be expressed by using a fuzzy set of the form. Let's see. There is a set A. If we take this equation, which is if we if we take this set A, then what we see here, that A is equals to x comma mu of A of x, where x belongs to capital X, where capital X represents the universe of discourse, and mu of A of x is assumes value in the range from 1 to 0. I will explain it once again. A is a set and X is an element which belongs to the set A. And there is a symbol which is called mu of A of X. Why we call it a mu of A of X? Because mu of A means membership function of the set A, membership function of the element X which belongs to the set A. That's why we call it a mu of A of X. Once again I am going to repeat it. Mu of A of X का मतलब होता है membership function of the element X which belongs to the set A. And here कैपिटल X इज द यूनिवर्स ऑफ डिस्कोर्स. यूनिवर्स ऑफ डिस्कोर्स का मतलब हमने जो बेस लिया है, इट मीन्स हमारा हमने किसको मानकर अपना सेट बनाया है. फॉर एग्जाम्पल, इफ द यूनिवर्स ऑफ डिस्कोर्स इज आवर एनिमल्स ऑन द अर्थ, देन the set that can be formed using it, the set of water animals, the set of birds, the set of insects. तो कोई भी सेट बनाने से पहले हमें पहले उसका एक यूनिवर्स ऑफ डिस्कोर्स डिसाइड करना पड़ता है कि इट मीन्स कि हम अपना सेट